Go. All right, folks, we are moving on to Unit 3 in our class, and you can see here in my Finder up on screen, I do have the first playground in Unit 3, so it's 3.2a, and the topic is instances, methods, and properties. And so I want you to go ahead and open that playground. Make sure you do the trust and open, and there's the playground. Let's start reading through this. All right. All right. One thing that I think is fascinating about app building
Ty,
is, yes.
I don't think you're sharing your screen.
Oh,
It's
no,
sharing for
I
me.
am sharing. I think,
Okay.
yeah, I'm seeing it. I'm following my own Zoom session on a school computer here, just to make sure. The other reason I do that, it's also a lot easier than triggering the Zoom toolbar to get your faces. Your faces are always up on the screen for me, and I find that helpful, especially when I'm telling jokes. All right. So whenever we're like coding and creating apps, we get into this mindset. And I think it's kind of interesting that we had a guest there for a moment who's actually thinking about an app and like a scenario for one. Because I did mention to you, it's always difficult to kind of imagine a scenario for an app that hasn't already been done, right? And so many apps have been created. The real trick is finding something unique or different or special that allows you to ramp up some technology and make it something important. But they make the point here that when you start to learn about programming, one of the most difficult things to do is kind of make comparisons to the real world. And they're talking about, connections to the real world, because then that grounds you in what's functionally workable in an app and in programming both, right? Because what good is a program that doesn't solve a real problem? Is really the point. Now, they use this word instance, and this is a really important word in programming, and they're using the car as the example. So let's kind of read through what they're saying here. It says, for every type in the real world, there are many actual physical instances, and they talk about a car. It says, for the type car, there are countless individual variations. So there's different models, brands, submodels, vehicle types, and then those vehicles, even if they're the exact same make, model, and type, they're still unique. Like even if they're the same color, like if I had a Subaru wagon that's white, right? There's probably like 1,000 of those, just on the east side of Milwaukee, because everybody drives Subarus, it seems these days. And what makes them unique? Well, the license plate makes them unique, and they might have different scratches on the car or dents. That's the point that they're making here. And one's got, different types of tires, or who knows, right? But despite the fact that they're functionally identical, they still are unique vehicles, right? And so something that is of a certain type can be very similar to all the other ones that are of the same type, but it's still unique despite the fact that it's of the same type. And this is a real important takeaway. The other thing that they kind of bundle into this, so there's kind of like this basically aspects, or let's call them properties of that type, right? So like the history, make, model, color, fuel level, scratches, dents, those would all be like properties of the car. But cars also have behaviors. For example, like the brakes on your Subaru might not feel like the brakes on mine. Maybe your pads are almost worn out and mine are brand new, or vice versa. Or maybe the other person's driving one and the brake fluid is low because it's leaking, and they're squishy and doesn't really stop the vehicle, right? And those, I would call those behaviors. Like right now, I'm driving my Volkswagen Golf, and it's been shifting weird. Like sometimes it doesn't want to shift, and this is a manual car, so shifting is kind of important. It tells me I should probably get it checked out or service it, right? So it's got its own behaviors that also make it unique. So it's got properties and behaviors. They use another example. Take a city, for example. It says each instance of a city has a different name, population, location, and landmarks. And a city has certain methods for getting things done, like responding to emergencies or collecting garbage, right? So that would be like on a city level or, the car, right? It says the type defines or describes the properties and behaviors of a particular kind of thing, but each concrete example of the type, each car or each city, is a separate independent instance of that type. They are still unique, even if they are seemingly identical, right? So it says, imagine two cars of the same make and model, built in the same year. One is speeding down the highway on a trip, but the other is out of gas by the side of the road. Same type, two different instances. Okay, so just kind of playing on this. Or think of two cities. The location of each city will be different. A landmark in one city might draw lots of tourists, but a landmark in another might be in disrepair and get few visitors. Both are cities, but each has its own individuality, basically. In programming, we can use different instances of a given type, and each one has its own set of property values, and each instance can perform independent behaviors that are separate from the others, right? So that makes sense, right? I'm hoping you guys are kind of latching onto this concept. So it's very much the same, but they are yet unique and can do different things. All right, let's take a look at this from a coding perspective now. It says you've already worked with a variety of types in Swift, such as a string, right? An individual string like hello is called an instance of that type, right? So literally, right? So a string is a type. Hello is an instance of string, right? And then I could also type hello with a capital H, and it does make it unique. I could also type it with all lowercase again, and it's still its own thing. Isn't that kind of interesting? You've been creating instances of type int and string for a while now. In fact, each value you make in a program is an instance of its type. The constants hello and a different hello are two string instances that happen to hold the same data. This is a really good example, I think, from the author. So two different names, but what's inside is the same thing, right? They're functionally the same. They just have different names. Now, what type something is does have an impact too, because it changes how you use it in your code, right? And how you process it. And you've seen now that you can join strings together, for example, or you can take integers and do math. But there's a lot more that you can do with individual instances of stuff. So let's move on to the next page here. All right, let's get to the point where we're creating an instance. And so far you've created almost every instance by typing a literal value directly into code. The exception was in the types playground where you used date to create a value holding the current time, right? All right, so here's some example code. And I will make special note here that because we are including the date function, they also have to import what we call the foundation library, which allows us to use the date function because that comes from this library, right? So if you're wondering, why is there an import statement? Well, in order to use the date function, I have to pull that in. That's the why, right? Common thing in programming, by the way, like when you're writing much more complicated programs, you don't want to sit there and reinvent the wheel. You don't want to write everything from scratch. If somebody's already got something written that does something, you just use it. I don't care how date operates. I just call it. I import its library, I call it, and then I have a date. This gives me a date and timestamp right inside of my program. And you can see the output here in the sidebar. The other takeaway here is that they're also showing you the difference between a literal value, right? And this is an very important programming construct, and then a value that is uncertain, right? So for example, and notice how they're putting the word literal string, right? Because I literally typed the string here, and you can see it. It's inside double quotes. I can see the letters. It literally says howdy. And so it is a literal string, right? For a Boolean value, false, well, this is how we declare true or false in coding, and we just say false. Notice how it's color coded, which means it's not a string, right? It's a reserved word which represents false. And then for a number, in this case, it's an integer, that's also hard coded and is literally a value. So this is literally a string, literally a Boolean, and literally an integer. Interestingly, this is not a literal because I'm not literally typing October 17, 2023 at 3:30 p.m. If that's what I typed in and put it in double quotes, then it would be a literal string. The date function, conversely, must run, do something. And what it does is it talks to the system and says, hey, what day and time is it? Okay, thanks. And then puts it up on the screen formatted for you, right? That's what that does. But it is not a literal, right? It's the result of running a function. So it says date looks a lot like a function, but with an important difference, it uses a type name instead of a name beginning with a lowercase letter. So the takeaway here is you have a capital letter that starts it out. This is an example of what we call an initializer. You use an initializer to create a new instance of a particular type. Only a few types allow you to do this. String is one of them, and it's an important one, obviously. Boolean and int, right? They can be created using literals, but every type has at least one initializer. And so what they're really trying to point out here, and this is very true in object-oriented programming kind of across the board, by the way, is they have basically a function that's built into, we can think of it as a data type that constructs an empty version of that object, just basically waiting for it to be populated. Now, the date one does go out there and pull in a value from the system because that's what it's designed to do. So when it builds itself, it goes to the system clock and pulls back that information. The other ones, though, in this case, are constructed. So we're kind of like creating a thing for it, but we're not putting anything in it yet. But I have the construct sitting there to accept a string or a Boolean or a number, an integer in this case. So there is that mechanism is in place so that when I'm storing it here, it has, so I can't just type a number and put it in empty string. It's going to have to be a string that goes in there ultimately, one way or another. We don't know how it's generated at this point. That's not the point. We are taking, in this case, a constant. It could be a variable as well. And we are initializing it, meaning we're giving it a preliminary structure, not necessarily putting a value into it. And I know this is kind of a deep conceptually. I know for me, when I was like first learning these concepts, and I have like a recollection, I was like in my C programming class back, we're talking like, 30 some years ago here. And this is being explained to me and I'm like, I don't get it. And I went all the way through my bachelor's and master's program and I was still kind of like, I still kind of don't get it. And here's the problem. The person explaining it to me, they were brilliant. They were great programmers, but they weren't really good at explaining the concept, right? And so what I'm trying to resonate with you guys is we can take, a declared value, either with a let statement or a var statement, and tell it to be of a certain type without necessarily populating it with the value. It still is the thing. It's just kind of empty right now. That's all, All right. Next, it says you'll often want to provide more information when you're creating an instance. Many types have initializers with parameters. So like the date, for example, if you don't like put in a parameter, it just automatically pulls back the date. But I can also control it. And it says time interval since now 3600, which is a special parameter for the date, type that says add 3,600 seconds to whatever the time is right now. So if I run the date function up here, when I ran it, it was 3:30, 3,600. If you want to do the math on that, is 60 minutes, which added an hour to the time. So via a parameter, not only pulled back the system clock, but I added some time to it. So for example, like if you're doing a calendar entry, you might use something like this, where the one appointment starts now, when does the appointment end? 1 hour from now, and it's done programmatically like this. You don't have to like do anything special. You just have to call it the right way. Okay, so this initializer gives you a date that is a number of seconds from the current time. And it says initializers and functions are similar in some ways. So this is kind of a takeaway here. They can have parameters or no parameters. Just depends on the type, by the way. You can call them the same way by passing in required argument values. So like if like date is expecting something in there, you can put it in. It may not have to. It just kind of depends. But they also have a difference. And the difference are these. You can use the name of the type when calling an initializer. An initializer returns a new instance of its type. And this is kind of like, sounds fuzzy, like when you're reading it, right? So this is why I spend a little bit of time on this. The initializer creates that container that will only fit that type of thing, right? So once again, if I'm initializing an integer, I can only put integers in there. I cannot put a string in there. All right, so hopefully that helps. But the interesting thing about any of these that start with a capital letter that are considered types, and I'm going to actually maybe even go down a limb, we can call these data types in a way, right? In some cases, they're really class structures, but because they start with the capital letter, sometimes they have extra capabilities that are attached. Now, we've already kind of played with this stuff, not knowing what it's called, but now we're going to learn, you know, the formality of it. So it says functions can be defined as part of a type. So if I have a definition for an integer or a string or whatever, and by the way, you can make your own types as well. Sometimes you can make functions that go inside that type, and then you can call those functions out. And once you call those functions, they're really referred to as methods, right? What are methods then? Methods are functions built into a type. And so therefore we call them either just methods or instance methods. And many of us will also call them functions because really they are functions, but because they're part of a type, we call them instance methods. Methods, you know, the short. So string in particular has a lot of common methods we've already explored, right? So we just did the question bot and we used this method called hasPrefix. And the way that one works is you put some, you know, letters into the double quotes, and then it looks at the beginning of your string to see if, does it start with this? That's what hasPrefix done, is that do the characters of the beginning part of your string look like what's inside my double quotes, right? So that's considered an instance method for a string. All right, so let's read what it says. It's often useful to know if a string begins with another string, hasPrefix, right? We already did that. It says the method is declared like this, right? So this is how it's done inside the string type, right? So they have a function, they name it, they have a, what do we call this? An argument label, right? Which doesn't have a name attached to it at all. So that means you can just throw whatever in there you want. And technically it's a prefix and that's a string. And then it tests to see if your string matches the other string, and the result of it is a Boolean. It's either true or false. So does, you know, where is McDonald's have the prefix of where? And the answer would be true, as long as the case is the same, right? That's kind of the point here. All right. So notice once again, there's a separator, the period. And this is how we use it. So we take a thing that is defined basically as a string. And you know, its introduction up here is a literal string. It literally is a string stored in here. So that string, because it's of type string, has access to all the methods that are included in the string type. hasPrefix is one of those. So any string that we have, we can append to it dot hasPrefix, stuff in double quotes, and then it just does it. It runs that function or method to check. And then you can, you know, compare it, right? So for example, this one is, it was a dark and stormy night. hasPrefix it was, true. hasPrefix it wasn't, false, right? Makes sense? Could I, like in like right now I have introduction highlighted. Could I replace this? And you know what? Here's what you do. If you're asking a question like that, is try it, right? So could I just literally put a string here and say, okay, well, here's the word introduction as a string. Does that work? Well, yeah, it works because that's literally a string. See, and this really explains it pretty well. It's not a constant or a variable. It's literally a string in place. But because it's of type string, because it's literally a string, I can use the string type method called has prefix. And of course, it comes up false because it doesn't have a prefix of it was. But if I said, you know, it was, and I'm careful of case here, should this flip to true? And it will. So I'm going to control Z that, by the way, but that's a really good little example of what I'm talking about. So this, okay, so they say this is known as calling a method on the instance. Okay, I never use that terminology, but that's, the Apple people tell me that's the way you say it. All right. So you've called has prefix on introduction. Okay, and then we see all the outputs, and I think they're basically, okay, right. So here's kind of the takeaway on this. What methods are included with a type are actually contained, there's libraries of these things, right? So when people create a type, there's documentation that says, okay, what are all the instance methods for this? And Swift, like all good programming languages, has basically user documentation or what do we call it, like manual libraries or whatever, that show what all the instance methods are, right? When I teach my Java classes, by the way, that's kind of a big thing in Java, because like sometimes you use stuff and it's like, well, is this the method you use to do this? I don't remember what it's called. And you just look at the documentation and go, oh, here's one. That one will do what we need it to do, right? Not like you have to memorize these, by the way, right? You find out how to find them is the polite way to say it. All right, moving on. All right, type safety still applies when you're using instant methods. So has prefix is intended for strings, so you can't use it without an instant. So you have to have some sort of string to work with in order to use it. And so like if I uncomment this, and I can't just call it like that, because that's not how it works. If I put a literal string in front of it, a dot, then this will result to false, obviously, right? Or if I had a variable declared, I can call it, but it cannot be standalone at all, right? So you have to have the type available to run it, because it is intended for that type. It says you also can't use an instance method on the wrong type, right? So like if I try to use has prefix on a number, which is an integer, and I uncomment this is going to throw an error and it's going to say, hey, this is the wrong type, right? I don't even know how they say it. It says error value of type int has no member, has prefix, right? So they're going to integer because they recognize number is an integer is a type. They're looking for the method called has prefix, and there is no such thing. That's what that error message means. If that was interestingly, if I just convert the number 42 to a string, then forces it to a different type, now it works. Right? You see the connection there? And hopefully this resonates with you a little bit. All right, let's, I'm going to go ahead and comment that out once again. Let's move on to the next page. All right, now we'll talk about properties a little bit. And I was kind of touching upon this earlier, so now we'll just go just a little bit deeper. It says at the start, we looked at city and car, right? And each instance having a different name or different type of car, having its own mileage or whatever. In Swift, each instance has one or more pieces of associated information, and we call these properties. And I think I mentioned that before. It's often useful to know if a string contains any characters at all. The property is empty answers this question. So let's take a look at how it's declared. So we set up a variable, we call it is empty, and we're pointing to a Boolean, and then we say get. So this is what they're telling you is they're looking at where this thing is defined. The what's being returned really truly is a Boolean, and we're getting the thing in there, and we're looking to see if it's empty. So in other words, if I put in empty double quotes, well, that's empty, right? So that's going to return false. If I have something in between there, even a space would count, or an emoji, heck, would count on a string, then it would come back as, well, actually, that would be the reverse. So think about the question here. Is it empty? Okay. And often when we have methods that return a true false, we often preface them with the is keyword. So is empty, if I have an empty string, what would be the result? True. Is it empty? True. It's true that it's empty. Then I type something in there, and then it's false that it's empty. Right. So see like how that's structured. And it says it looks similar to variable declaration. And just as a method function is built into each instance of a type, a property is a constant or a variable built into each instance of a type. All right. Now this is kind of like very theoretical, like in terms of conception. So I hope you guys are hanging with me here. The property is named is empty and is of type Boolean. It is marked a variable because the property value could change if the string contents change. So for example, I could start out as a variable that's empty and then type some stuff in and store it, and then it might go back to empty again. Who knows, right? So that's why it's declared as a variable, because it could change. If and I want you to read this. The get indicates you can only get the value of this property, but you can't set it. So in other words, it's kind of like, do you have gas in the car? It's either a yes or a no, right? Or do you have tires on the car? Or is your tire flat? It's a yes or a no. Doesn't mean you're changing the tire, right? That's a separate method, by the way. Properties are called by using a period after the instance, but notice the interesting aspect of this. There are no parentheses here. We kind of did this already too, right? So if I set a constant called something, and it was the best of times, right? And then I take that string, literal string, and then I run this property. This is going to return true or false. Is it empty? Well, the answer is false, right? Yes, it's false, because I can see right here, there's something in there. This is not letting me change it, though. I can't like put parentheses and change it to something else, right? I'm just going, hey, are you empty? All right, you're empty. Great. All right. Is this empty? False. There's something in there. Here's an example of the empty string, and that triggers it to true. Hopefully this kind of resonates. One of the keys to knowing if it's a property or a method often are the parentheses, right? And it's kind of a fascinating little thing. The same type safety rules apply for properties as with methods. You can't use a property without an instance. So you have to have something to attach it to, right? You can't just run is empty. Well, is what empty? You have to attach it to something. You can only use properties that are part of the instance type. So I can't use is empty maybe on a number, but I can use it on a string, right? So I hope that makes sense. That's really what they're trying to say. And let's see what their note says. It says, types you've worked with so far don't have many properties because the information they store is very simple. You learn more about complicated types in a later lesson, and we are going to do that. And here's the other interesting thing, because we're talking about types and their methods. What's kind of fascinating about that is you can create your own types, and that's kind of where we eventually lead to. And this is a common thing in programming. So you might have some sort of a construct that you're trying to represent, a car, a city, whatever, a guitar, and then you can imagine for a guitar, it might have property, active pickups or passive, 6 string, 7 string, whatever. So maybe a property for guitar is 7 string. And that's either true or false, right? right? And that would be something where you're creating the type and defining it, and therefore you can control those aspects. But what, if you want to make the tie back here to the first couple of slides, the whole point of talking about the real world thing is the moment I start thinking about something real like a guitar, which speaks to me, all of this stuff resonates. Where, if I'm checking to see if it's a property, is it a 7-string versus a method which does something? So like the volume knob might be a method that does something. It turns up the volume, so I could like set the volume to 10 or set the volume to 5 or set it to 0. You see what I mean? And that actually functionally does something, whereas a property just checks to see where it's at and doesn't allow me to change it. So here's the example that they have here, and this is a string. So they start with a variable, and they start talking about this really weird aspect of it, which is when you have the capability to compare what a property does to a method, there's a bunch of different aspects to this, and this is really kind of fascinating one as an example. All right, so what's the difference between the two? Okay, so the difference between a method and a property is similar to the difference between a function and a variable or a constant. A variable is useful for referring to a value, but a property provides you a way to actually get or set a value. And the words get and set become really important here, by the way. Get implies we're retrieving what's there. Set implies we can change it, right? So that's a really big takeaway. Each instance can have a different value for that property. So like one car might have gas, the other might not, okay? A function is useful for providing behavior that can be repeated as needed. A method works in the same way, providing behavior specific to that instance. Okay, I think we proved that already. All right, arguments. If the work you want to perform needs extra information, then it must be a method, right? Because only methods can have the parentheses, and it's making the point you cannot pass arguments to a property. That's a distinction. That means that has prefix must be a method because you need to pass it in the prefix you're testing for. Okay, hopefully this all resonates with you guys, but a property doesn't have that because we can't ultimately change it or manipulate it. Side effects, it says if the work has side effects, things happen that aren't related to the return value, then it's a method. For example, string has a method called remove all, which empties the string. Could be useful, right? So here it is. The variable is called magic. Now you see it. Then we take magic, we remove all, and then we just put magic back up on the screen and you see that it's empty. It'd be kind of nice if it said, now you don't, but we are removing it. So, I mean, the case in point is right there, right? So that is what then? Is this a property or is this a method?
This is a method.
Yeah, this is absolutely a method. The parentheses are the giveaway, right? The other giveaway is it does something and changes it. Changes the object that it's attached to or the type that it's attached to. It says properties are for getting values from an instant. As you will see later, setting values on an instance also, that can be done. Properties don't do any additional work. You can get and set, and that's about it, right? But those are important, by the way. It says, interestingly, often when you're working with types, that you can use both of those simultaneously to kind of like test something and then change it. Like, is this empty? Okay, let's put something in. That's I think a good example. Let's move on this concept now. So now we also have this concept of the API, and the API is one of those things that as programmers, we go through all this rigmarole to learn how to code from a really fundamental level. And then you get out into the programming world as a professional, and then people are like, oh, you're not coding that. We're just using this API, right? Which means from a programming standpoint that intelligently, if stuff is already built that you can just use, you just use it, right? Like, so if I want to cook a pizza, it doesn't mean I have to build an oven. I mean, I just turn the oven on and put the pizza in. That's kind of what like the API equivalent is. So API, of course, stands for Application Programming Interface. And we played with that BoogieBot thing, and there was already all these things for like shake it and boogaloo and raise your arm and whatever. And then if you wanted to change what it's doing, you just control the API. You just call the methods from the API, and that just does the work. Now, here's kind of the takeaway on this one. So there's a lot of ways to find out about the API that a type offers. If you can sort of remember the name, and a lot of programmers operate like this, by the way, I'm like, I think it's one of those is ones or has ones. You just start typing the word has, and then it'll bring up a whole list. As you know, the IntelliSense will bring up a whole list. And they're like, oh, that one says string, that says string protocol, that says into, I'm not sure which one is which. And then as you're hovering over it, it also shows you, what the expectation is for a type. Isn't that interesting, right? So like, how do you know? So it says if you can sort of remember the name of a method or property, you can just start typing it. Xcode will give you auto completion suggestions, and programmers use that stuff all the time. Absolutely. Why wouldn't you? Right? Right. Here,
What's the,
yeah, go ahead.
sorry, this is a little like maybe out of the scope of what we're learning right now, but what is the difference between string and string protocol there? If they're both like kind of like the same kind of
Yeah,
has
that's a great question. I've never coded anything with a string protocol and stuff, so I couldn't answer that.
Yeah, I haven't seen it either.
No, but here's what I can interpolate and guess, because I know that the word protocol means a set of rules for communicating, right? So the string protocol might force it into, I don't know, like if it's the beginning of a sentence, it has to be capitalized. So it might check, just for example, it might check to see if the first letter is capital. And this is a guess, right? It depends on what the protocol is. So there might be a follow-up to that. So you might have a prefix, you apply a string protocol, but then you might have to declare upper and lower case, or this needs to be in French, or something, who knows? But yeah, that's a good point, right? Like, what does that mean? I'm not sure. How would I find out? I would research it.
Yeah.
And the other thing that happens here is when you are pulling the stuff up, there are tools built right into Xcode that let you look the stuff up. So I teach the same thing in my Java classes, where we teach people how to like, oh, I don't know what this is empty thing does, so I'm going to look up the Java doc on it, and good IDEs will let you do that internal to the product. So they might go out to the web to pull in the information from some repository, but it'll do it right in the product and give you a whole explanation of like what works, what doesn't, how to use it with examples even sometimes, right? And often what programmers are doing is they're looking at these things in libraries of methods and functions, trying to figure out which one is the appropriate one to use. They'll usually play with it a little bit until it does what they want. And then later on, you might discover, oh, that's not even the one I wanted to use. I should have used this one, right? Somebody already built that. Right? And that's very common. And it says, don't worry if most of these options don't make sense right now, right? And I get that feeling totally, so I can relate to you guys. And it says, you can see has prefix, which you know about, and you can probably make a good guess at what has suffix does, knowing what has prefix does, right? It's just an intelligent thing. As you enter more characters, fewer options will appear in the list, and you can use the cursor keys to select an option. The tab key to complete it, right? So if it's starting to, right? Or you can use enter, and then you can just keep right on typing. But if you use the tab key, and this is kind of the takeaway on this, it leaves you in the same spot where if I use the enter key, it moves me down a line, right? So just as an example here, if I type text and then do dot has prefix, and you see how I'm arrowing down. If I use tab, then I'm ready to keep typing, right? So that's really kind of what they're trying to point out. I am Control-Zing that or Command-Zing that to get off the screen. All right, let's try the exercise here. It says use auto-completion pop-up to access is empty, has prefix, and has suffix. Like I guess I kind of did that already. And then try that on basically example. So we have an example string. And so what they're telling us to do basically is we have example put up on the screen already, which contains a string, so the sidebar just shows the string. But now they're expecting us to add to it. So I just put in the dot. Everything that's possible comes up when I put up the dot, right? And there's a lot of stuff in there. But let's try the ones they're suggesting. Is empty. Okay, that's a Boolean, no parentheses. Look at the sidebar, false. Now I'm going to suggest that you go to the next line. You could just like replace it, but let's do has prefix. We just did that one. And let's just put, whatever. It should come up false, right? It's false. And then let's do example again. And we'll do has suffix. And let's put one in that'll ring true, say times, and that should come up true. This is, once again, I think we've kind of already been doing this as we've been working, but maybe you really didn't think about how it's working, I think it's kind of interesting though, notice that what Swift does that's very helpful is they tell you, see the little P right here? And see the little M right there? It tells you if it's a property or a method. So I think that's really helpful, right? That is not necessarily typical in IDEs. I do like that, and I do think it's helpful personally. All right. So it does say APIs also come with documentation to help learn about them and see how they should be used. And good API documentation will not only describe all the methods and properties, but then we'll show you examples for each one. A well-written documentation sheet should do that. All right, you guys, I think we should take another pause here. So let's do another 5-minute break if you guys are cool with that. Maybe
Sure.
like 7 minutes, and we'll come back.
Okay.
All right, we're back from break and we're going to move on to the next page here. So we're going on to page 9. And here's an example that's really, I think, kind of helpful for the moment, right, on what we've been talking about. It says, what does this do? It says, one of the most important skills you develop as a programmer is how to find and understand things in documentation. And you know what? I completely agree, right? Because there's no way, right? And I always tell the student, there's no way you're going to memorize this stuff, right? You throw in the fact that you're learning one language and then a different language, and then that language has 20 tools, and then it upgrades, and then you're working on a Mac and a PC, and it's like, how are you going to know? You just don't. So one of the most important skills you have working in technology is the ability to find information when you need it. And real frankly, they can do so when working in Xcode by using this really simple little trick. And the trick is called option click. And you can option click on top of basically any of the keywords inside of your code, and it will bring up a panel like this. And then it gives you, all right, tells you what it does, the summary. It will give you a declaration, like how do you use this, right? Or what's the setup for it. And then it'll also give tangible examples with what the output or the result technically should be. And this is a really good example. Now this is truncated. So you'll notice that, they kind of get to a point and they start talking about parameters, but that's off the bottom of the screen. A lot of these, when you do bring them up, you can scroll down and keep reading. So what they really want you to do here is to come to some of these keywords like has prefix, hold down your option key and do a click. And do you notice what it did as I did that? Like I'm over it. And the moment I hit option, it changes to a question mark. And then you click and it brings up, okay, the real quick description, which shows you how you call it, what it's expecting as a parameter and what the result is. In this case, a Boolean. We feed in a string and we get a Boolean back. But then you can also do this where you open it up in the documentation and you can start like reading more in depth how it works. Now, this one doesn't really seem to have a lot of stuff in here. And I'm wondering if it's relative to the information. I guess this is kind of basic, but I was expecting for a little bit more here. I'm actually surprised at how limited this is, right? Compared to the example that we looked at. And maybe I didn't click the right key sequence or something.
I got the same thing as you did.
Yeah,
Okay.
same.
You know, and what they're trying to have us do here is you can also option click on anything, right?
Well, I did find the information for Boole.
Well, that's good.
Yeah.
You know, you notice how I say that, right? Well, I guess that's good. All right, yeah, here, this is a better example, right?
Yep, that's what I'm seeing too.
So, I mean, just more information there. This kind of stuff is really, really helpful, though. I mean, I think that most of these are, I guess, kind of so simplistic that they're not really. I'm not sure why it's so simple here. Oh, right, because and here's the reason why. This is actually a property of a bigger structure, which is a string iterator. Okay, so whatever that means, right? And here's some of the explanation of that. And really what you ultimately want to do, this is all probably part of strings. So if you go way up the tree, you'll see that strings have a lot of functions and methods and properties attached to them. And then you can, hey, read to your heart's content. Sometimes, you know, I've done like coding where it's like, I had no idea something existed and I just found it in the documentation and tried it. I'm like, oh my God, this is miraculous. I wish I would have known about this before, right? But sometimes you don't know until you look, is kind of the point. All right, so play with that, but just always remember if you're working with code, especially if it's pre-existing and you're not sure what it does, well, you can look it up. Or if you're trying to create code and you don't know which method to use or property to use, look it up, see what's available, and then kind of branch from there. All right, another little thing, it says, in addition to the popover appears when you option click, you can find the same information using the Quick Help Inspector. To view this, make sure that the utilities area is visible. So you got to go to View, Inspectors, Show Quick Help. View, Inspectors, Quick Help. All right, so you see how I bring that up? Now it brings up the panel. And then whenever your cursor is positioned, the Quick Help Inspector will tell you about the code at that point. So for example, if I click on Foundation or Import, okay, that's not really very helpful. Well, there we go. All right, so now on Has Prefix, right? See how it brings up that little information. All right, so whatever. If you find that helpful, fantastic. If you don't, you can turn it off. I'm not a huge fan of having that turned on. There are, you know, let's just say there are times, you know, where it's helpful. I'm not seeing that right now. It is, they're just kind of showing you where the tool is more than anything. And they're asking you to just, you know, experiment, basically. All right. The other thing is that there are documentation pieces that go deeper. And I think this is important. It says the popover and the quick help are great, basically. And they do get all their information from the same source. So that, like, my equivalent of talking about the Java docs in Java is kind of the same way. But you have to go to wherever that API is formally defined, and then you can see the full documentation when you click that link, supposedly. You can kind of tunnel through and find the stuff that you need. So here they're asking us to open the documentation viewer as instructed above and search for string, right? So here, what they're asking us to do is go to Window, Developer Documentation, and then I can search for something. So for example, I can search for string, and there it is, right? And then you can read to your heart's content, right? And all the different stuff that strings can do. There's properties, there's methods, and I kind of expected to see more than that, but this is for the string iterator, whatever that means, right? All right, so that's the way you kind of do it. One of the problems, okay, and they're making a good point of it, and I sometimes struggle with this too, is when you look at the documentation, it's kind of like, hey, I want to look up this one thing, and then it's kind of like, you pull out like, I don't know, an encyclopedia just to find one sentence. You know what I mean? You're looking for that one sentence, but you have the whole encyclopedia set handy. So it can make it feel a little overwhelming. So what your job as a programmer is to weed through the nonsense and get down to the point where you're using the stuff that makes sense to you, right? So being able to do the right search is very, very helpful. All right. Let's move on to this next thing because this does become pretty important here for us. And we're going to start learning about a couple different constructs and their names and how they're used and kind of what they mean. And it says here, as you look up APIs in Quick Help or the documentation, you'll see type declarations like the following for string. At the top of the pane, you'll see the declaration struct string, right? And all right, so even if you've had previous programming experience, you probably have never seen that keyword before. This is kind of unique to Apple Swift, but a really, really important construct, if you will, because that's kind of what it implies is it's a construct of some sort. The other thing that you'll notice is if something isn't, for example, a struct, it might be a class. And these are two very different types of things, but knowing that there's a difference helps you understand how to work with it. And here's their helpful tips. It says, as you build apps in Swift, you'll work with instances of both struct, short for structures, and classes. And both of them, and this is important, both of them allow you to define types in Swift, and they function differently. So here are their features, basically. Here are the similarities. The similarities are that both have instances. Instances are created with an initializer of some sort. Both can have methods and both can have properties. All right, so then kind of what's the difference? All right, well, that's the big question. So it says when you create and use instances, you write the same Swift code, whether it's a type or a struct or a class. It doesn't matter which one it is. For the remainder of the course, you get more practice creating instances and properties and methods and all that. And then later on, you'll also learn how to define structs of your own, which is very helpful, by the way. And exploring these differences, they're saying is beyond the scope of this course. But when you take the second level course where you talk about that stuff more deeply, we do get more into what really is considered object-oriented programming. We haven't really delved into that yet, but when we use the word instance, that kind of implies objects and classes anyhow, which is why we use those terms. All right, so here's the question: why methods and properties? And if I was just to answer that without looking at the screen, I would give you like my whole spiel about it. Here's my spiel, okay, before I read this to you. My spiel is, why do we have methods and properties? Because those are things that travel with the type and expand the capabilities of the type and also make it unique all at the same time. So you can not only have this thing, the thing does something. Great example is a car, right? We think of the car as a car, but the car does all sorts of stuff, right? And it's just a matter of us accessing those capabilities. All right, let's see what it says. So it says, with methods and properties, each instance of a particular type has some set of values that you can access and some behavior you can use. Methods and properties help to break down the complexity of large programs by putting related pieces of information, properties, right? And I often think of properties when I'm doing Java, I think of it as the data fields, right? So that, information, properties, they kind of go together, and the work to be done, or the things it does, which are the methods or the functions. And then they carry together. So you have information that makes them unique, and then aspects that allow you to do things, is the polite way to say it. Take string, for example, you could write a has prefix function outside of the type that takes one string to test another with the prefix. You could do that. It's not hard to do, right? Conceptually. And then you might name it like that. So you might name it, function has prefix, you feed in a string, and then you have another string that it's comparing it to. So what's the prefix you're looking for? What's the string you're feeding in? And then I could easily return a Boolean, and say true or false. And that's basically what people did when they created the struct of string, is they added this to that struct, and then you just call it and use it rather than create it. So this kind of function is called a top level function because it isn't contained in anything else. All the functions so far that you've written are top level functions, user created, maybe is even a good way to think of them. But there are significant advantages to using methods and properties over top level functions and variables. Putting the capabilities of a type together with a type itself makes the code easier to understand. So when you have a string constant or variable and you're attaching a method or a property to it, it is implied that they go together and you have that capability. So they're connected, so of course it's easier to understand. Auto completion works much better. So the auto completion really works on the fact that if it recognizes that something is of a certain type, then it goes to that type in the libraries and the documentation and pulls back the documentation to help you do the autocomplete. That's how it works. So if you like IntelliSense, it is all driven by that documentation. That documentation is driven on the fact that we have properties and methods attached. It's also easier to find stuff in the documentation because generally, if you're looking for a top level function, well, then you got to dig through the person's code to try to find it. And chances are if they wrote it manually, they probably don't document it there. Whereas if you use something that's pre-built, it's fully documented and easy, even to search stuff on Google to find, a thing, So if you were working with somebody's custom function and then you wanted to look it up, maybe they didn't even have that included in their program in the form of comments or something. And then you have to go somewhere else to find, what a pain, right? Like who's to know? The other aspect of this is it hides the complexity of programming. So you think like the BoogieBot, I don't care how it raised its arm, but it did it, right? And that, kind of falls on that black box effect, right? Who cares what's going on the inside as long as we can make it do the thing that we need done. And from a programming standpoint, this is kind of the refresher. Okay, so guess what? Now that we're wrapping this up, so here's all the stuff that we supposedly learned just now. We're going to return to the BoogieBot. Oh boy.
Oh,
Right. Oh joy. All right, so I think we've talked that stuff to death, but if you guys just want to look at this for a moment on the screen and read it, this is a synopsis really of what you learned. Let's go on to the BoogieBot thing now. Of course, hopefully your playground loads up and there it is, right? All right, so remember when you were using this before and you had to have a list of the functions that perform the dance move? BoogieBot in this playground is set up as a type. Interesting, right? So you can make an instance by doing this. So, and this is pretty universal, that if BoogieBot is declared as a type, like string is, then you usually call the name of it, add blank parentheses to it, and there's usually a method inside there that constructs it, right? And in Java and a lot of other programming languages, we call this a constructor function, right? This is the constructor that builds it. And so in other words, when you make an instance, you are constructing a version of it, and then we're storing that, albeit blank, inside this thing called leftbot, right? Now, just because we did it once doesn't mean we can't do it again. So here's the takeaway. I can propagate two of these. I use the same command, but notice I'm storing it in a different container. Now, this is really kind of bizarre because so far when we've been like using let or var, think about the stuff that we've been putting into it. We've been putting in a string or a number or a Boolean. Here's an example where we are taking BoogieBot, with all of its complexity, its properties, its methods, whatever it does, are all stored in this one singular constant or variable, right? Even though both of them are, functionally empty, it still travels with all its properties. The properties just haven't been set yet, and all of its methods. They are unique, but that the entire complexity of whatever this is stored in that singular box or container or whatever you want to call it. All right, so it says if you're thinking of thinking that a dance off between two BoogieBots sounds like a fun, you're in luck. So we get to do this. This playground has another type built in to allow this to happen. And so this comes from graphical programming, by the way. We have to first, if you're going to have multiple objects of the same type, kind of in the same space, we create, and this is a common thing, we create a stage, right? And so there's a separate construct here that's just the container. It's the dance floor, if you will, right? So they have to go up on the stage somehow to perform this, and we are constructing one of those, and there's a stage. The other thing is the stage has the capability, it can record what's happening. That's one of its methods, right? So when I say stage, start recording, that's part of this whole construct. We give each bot a name. So we have left and right, and then there is a property, right? That's a property. And we're setting it, and I'm using all these keywords right now, right? We're setting the value to lefty and righty. Later on, if I want to see what those are, I can get those values. I'm like, what's this guy's name? What's that guy's name? Those are getting the values, assigning the values are setting. So get and set, real common in programming. So here we're setting properties. We're saying leftBot.name equals lefty, rightBot.name, rightBot.botName equals. Then once we have them named, we can put them on the stage. So the stage is called, we give it a property of leftBot, and we're saying, okay, what goes on the left? This one. What goes on the right? That one. Now, interestingly, the container for the stage is already pre-named to the same thing as the thing we're pulling in. But it could be, and what I'm trying to explain here is the name of the container that holds this could be left side, right side, or, top right, bottom left. It doesn't really matter, but it's just a container that serves as a property. That property, once again, is a complex object being fed into that property. So it's not like a number or a string, it's a complex object. All right, so you guys already had this run, but it says click show live view or use the editor options and toggle live view to see your bot. The API will now be available using auto completion of the dance battle commence. And, one simple way, by the way, to trigger it on and off is just to go to the previous page and come back, right? So just click back into it, and then it should load up and do its thing. And notice, since you guys remember how we work the BoogieBot, right? We fabulize, which is it colors it, and then it's like left arm up, left arm down, right leg up, right leg down, and they're doing different things, but it's a pretty short little dance routine. It does look like I've crashed here in Xcode, by the way. Probably wasn't a good idea to jump back and go back, but whatever, I did it. Okay, sorry. And now I'm locked up. So let's go ahead and see if I can practice my force quit command, which is Command Option Escape. And let's go ahead and force quit. Xcode, and we'll just relaunch. All right. And relaunching. Get that force quit out of the way. And now once again, it should launch and it's running and it seems like it's not crashing, which is great. It says use the instance methods of BoogieBot to build a fun dance-off between the two robots. The auto completion pop-up menu will help you out. There's no danger in calling left arm up already. All right, so now there is a temptation here that maybe this could be a an exercise, right? And I'm not gonna make this one, this is not gonna be something that you're gonna need to deliver. This is just for fun. I kind of feel like we've already done this. Really what they're trying to show you is that you can mix it up here. So if you want to like, I don't know, take the whole dance routine, right? And if you remember some of the commands, right, from BoogieBot, like shake it or whatever, you can, or maybe this would be, I don't know, whatever. Doesn't really matter what the order is. You could just like double it up for each of them, and then it should run, right, and propagate. The whole point is to play with it, right, and see what it does. But I do also want to show you that because left bot and right bot are these, okay, so I crashed again, are defined above as instances of this type. They are unique entities, and that's why we can uniquely control them, even though they're on the same screen. And I think that's really kind of a cool takeaway. All right, command option escape and force quit again. Makes me not want to do BoogieBot again, honestly. When it does come back up, I'm just going to go to the next slide or the next page, if you will. All right, so here it goes. All right, moving on to the freight elevator. Okay, so this is one that I do want you to try to code through. And I am looking at the time here, so we're just about out of time. So why don't we let's do this. We'll kind of stop at an interesting point here. Is I will end class and the recording right now, and my challenge to you will be between now and next time is to try to work on this exercise and the one that follows, and see how far you get. If you
Sure.
succeed, great. If you don't, whatever, we'll look at it together and we'll get the solution up there. Remember, you can always look at the teacher's version for an answer, but I would like you to try to struggle with it on your own and see if you can figure it out, right? All right, so this recording will end here, and then when we come back next week, we'll continue at this point. If you take a look at the kind of the outline thing, so we've covered part A. I think it'll be pretty reasonable next time that we might be able to get through two of these. We'll see, right? I'm not going to try to be overly ambitious on that. But I do want to try to cover stuff as completely as possible from the book. So,
Okay.
All right, folks.
Awesome.
I will see you next time.
Sounds good.
See you next time.